Hello everyone, this is the first lecture of calorimetry in which we shall discuss some numericals, basic numericals which are a part of the 10th ICSE syllabus. So let us start. The first question says, calculate the heat required to convert 3 kg of ice at minus 12 degrees centigrade to steam at 100 degrees centigrade. Given specific heat capacity of ice is 2100, specific heat capacity of water is 4200, specific latent heat of ice is 336 kilojoule per kg. That means this is actually 336 into 1000 joule per kg, right? We're converting it to joule per kg as we see that all these are in joule per kg only, right? And specific latent heat of steam is 2260. That means this is also we can convert, right? No. So here we see that minus 12 degrees centigrade ice is getting converted to steam at 100 degrees centigrade, and we are required to find the amount of heat energy required to do so, right? Now see, we need to observe the transformation of ice to steam. Ice at minus 12 degrees centigrade first gets converted to ice at 0 degrees centigrade. Next, ice at 0 degrees centigrade gets converted to water at 0 degrees centigrade. Then water at 0 converts to water at 100, and water at 100 gets converted to steam at 100, and this is the total conversion. Now why are we doing separately ice at 0 to water at 0? This part, that is part B and part D, these two parts are involved in change of phase, and since we know that in change of phase no temperature changes, means no difference in temperature occurs between the means changed phase and the previous phase. That is why see both are at same temperatures, ice and water, here water and steam, right? Now let us come to the first part of the conversion. First part of the conversion, that is ice at minus 12 to ice at 0. So heat required at part A will be mc delta T, because this is change of ice at minus 12 to change of to 0 degrees centigrade. Change of temperature is there, so we use mc delta T, right? This delta T refers to change in temperature. C is the specific heat capacity of ice, so QA will be mc delta T, that means 3 into 2100 into 12. Change in temperature is 12, because 0 minus of minus 12 will give you 12 actually, right? So there should not be any confusion in this part. Let us come to part B. Now in part B we will actually take ml, right? ml means mass into latent heat. What is the latent heat of ice given? Specific latent heat 336 joule per kg. No, 336 kilojoule per kg. Actually we have to convert it into 336 into 1000 joule per kg, right? Exactly. So QB is ml, m is 3 kg and L is 336, and then we have to multiply with 1000, right? And next we come to part QC. Here once again we see water is getting converted, water is being converted from 0 degree centigrade to 100 degree centigrade. So we apply mc delta T, change of temperature is there. This is not a change in phase, change in temperature is there, so we once again write mc delta T, right? Here m is 3 kg, C is 4200, and delta T is 100. 100 minus 0 is 0. 100 minus 0 is 100, right? Next we come to part QD. QD will once again be ml, because here water is being converted to steam, right? Both are at 100 degrees centigrade. That means change of phase is taking place, liquid state to vapor state. So ml 3 kg into 2260 into 1000. Now the total heat required, Q, that we assumed here earlier, let heat required be Q, that will be equal to QA plus QB plus QC plus QD. That means whatever the values of QA and QB and QC and QD will come, we have to add them up, and when adding them up, big value comes 9123600 joule, right? So this is the value that comes as a result of this answer. So the total heat required for the conversion of ice at minus 12 degrees centigrade to steam at 100 degrees centigrade is this much joule, right?